Good evening, my dear NEET 2027 warriors. The basic maths which you require for solving physics. And today we are going to do the geometry, basically the trigonometry aspect, where you will see lot of fundamental concepts which you'll be using throughout of physics. And in NEET exam, you're not going to ever get a direct question on geometry. Rather, geometry will be used for solving many physics questions. So many times it happens that you get stuck while solving a physics problem, and there could be number of reasons, and one of those reasons could be the basic maths. So that's why you are here to clear all your basic maths concepts. So let's start with mainly the geometrical concepts of trigonometry. Good evening. Hi, Tirteshwar, and all the amazing warriors. Say hello to each one of you, your new friends, your new companions, your new batchmates in the journey, whether it is 1 year or 2 years, right? This is your Captain Shreyas. So I am saying hello to all of you. And one way to always mark your attendance is to smash that like button. Okay. So quickly do that right away, right now. And in our previous lecture, right? So you can see it on the channel itself. This is our live section. Every day, by the way, 6 o'clock, you're going to have the 11th standard classes, and 8 o'clock, you're going to have the 12th standard classes. I've already started with the 12th standard classes for NEET 2026. So here is the time we start it for your 11th standard. And after every class, just like 12th standard students are doing it, I want you to also put up in the comment section the homework answer. All right. So the homework answer should be there in the comment section. So after every class, you're going to get the homework, and we'll be seeing those names in the next class. So every previous class homework, we'll be seeing it in the next class. Good evening, aspirant Jarusha, Kirtana, Priyanka, Ravi. Welcome. Harni. Good evening. Good evening. Nice to see all of you. Lovely future aspirants, future doctors out here. So I'm Captain Shreyas. I am the physics master teacher training kids for more than 13 years. Did my graduation from NIT Nagpur and my research from IIT Bombay. So here you are again to start your fresh journey in physics, and physics is going to be the game changer in NEET, isn't it? So let's tackle it, guys, step by step. And if you have your seniors, or if you are a senior who is in need of counseling, then 11th June, that is today, then 18th June and 25th June, we are taking up counseling slots, as in which college is best for you based on your expected scores and results. So whatever guidance you need regarding the drop or the NEET rank versus selection or post NEET guidance, whatever you need, please let your seniors know. Please book your slot. The link is there in the description box below. All right. So let's begin. Now, in yeah, in geometry, the first thing that you will usually need most of the times is the concept of triangles, circles, and trigonometry. Okay, so we all know what a triangle is. It's a three-sided figure. So there are some special triangles which you should be aware of. One is your equilateral triangle, equilateral triangle. The next is your isosceles triangle, and the last one is your right angled right angled triangle. And if it is not any of these, it is in general something, then we can also call it as a scalene triangle. Scalene triangle. So how do these look like? Let's draw it one by one. Starting off with equilateral triangle, it will be basically like this. All the sides are equal, right? Isosceles, two sides are equal. Two sides are equal. In right angle, one of the angles is 90 degree. One of the angles is basically 90 degree. And in a scalene triangle, nothing can be said. So we can just chumma, just draw some random triangle like this. Yeah. this is a scalene triangle where none of the sides might be equal, none of the angles might be 90 or equal, or none of the things might be as good as over here. So in this case, this is basically 90 degree. In this case, this side is equal to this side, and in this case, this side, and this side all are equal. Also to note is that the internal angles will be 60 degree. So this will be 60 degree, this will be also 60 degree, and this will be also 60 degree, isn't it? In this case, only this angle will be congruent, but it is not necessarily 60. They will just be equal. If this is 30, this is 30. If this is 40, this is 40. If this is 70, this is 70. So both the angles will be equal. That's all. Okay, but they need not be 60 degree. That is the speciality of isosceles triangle. Okay, this particular side sometimes is also called as the base of the triangle. This is also called as the base of the triangle. In a right angle triangle, this particular side, which is opposite 90 degrees, we all remember, it is called as the hypotenuse. Okay, not hippopotamus. Hypotenuse. Hypotenuse. One student had written hippopotamus. I'm like, okay, great. Good evening, Rumana. Hi, Nandu. Good evening, Manish. Hi, Rumana. Welcome. Welcome, Aishwarya. Hi, Lalu Raizil. Hi, Vignesh. You are in 12th standard and you're watching it. Great. You are clearing your basics. Good. Hi, at aspirant. Good evening. Good evening. So that is the hypotenuse. This is everything will be different. Okay. We cannot comment really anything about it. Now, certain more things in each case. Say, for example, this is side A, this is side B, and the hypotenuse is side C. Pythagoras says that C square is A square plus B square. This is called as the Pythagoras theorem. Pythagoras theorem. Okay, the hypotenuse square is the sum of the squares of the other two sides. That is a common thing which you should definitely know. Okay, very, very important. Here there is no such thing. I mean, the sides are equal, that's it. Here A is equal to B is equal to C. If this is A, this is B, and this is C, that's it. They are equal. Here, if this is A and this is B, or let's say this is C, and the base is, let's say, B, here you can just say A is equal to C. That's all. Here, none of the sides, none of the things are going to match. These things are absolutely clear in your head. Everybody, give me a thumbs up. Okay. Now, the next thing that you should know in case of a triangle is that if at all, you have a triangle like this, and this is the base, and if you draw a perpendicular, that is called as the height of the triangle, then the area of the triangle, is nothing but half base multiplied by the height. Half base multiplied by the height gives me the area of that particular triangle. Very good. Excellent day. All these things, again, very, very important. Now, the next important thing which you should know, if at all you have a circle, and you take any diameter, what is this? This is basically the diameter of the circle. This is the center. Then, if you subtend an angle from the diameter anywhere, let's say over here, for example, or maybe somebody else might subtend an angle over here. It doesn't really matter where you subtend it, but wherever you subtend it, that will be basically 90 degrees. That will be basically 90 degrees. Very, very important. So it automatically becomes a right angled triangle. So that means the diameter becomes what? The hypotenuse. Automatically, it becomes the hypotenuse of that triangle. Again, a very important property, my dear students. Very important property which you should definitely remember. Okay, till this point also absolutely clear? Very good. Excellent. Next important thing, the next important thing which you should again obviously remember. See, now that we have talked about the triangles, what are the types? Many times you might have to compare the triangles like this. Say, for example, you might have a triangle over here versus another triangle over here. They look similar in nature. They look similar in nature. Now, what is the meaning of similar triangles? So, when triangles are similar, the immediate meaning of that is that, say for example, if this angle, if this angle over here is alpha, this angle over here is beta, and this angle over here is gamma, then angles over here are also the same exactly. This is also alpha, this is also going to be beta, and this is also going to be gamma. But their sides are of different lengths. Everything is of different lengths. That's it. But the angles are same. So when triangles are similar, immediate meaning you should understand that all the angles are same. All the angles are going to be the same. Very, very important. But if you take the sides, let's say this is the side A, let's say this is the side C, let's say this is the side C, let's say this is the side B. Same thing over here. Maybe we can call this as the side maybe P. Let's say this is side Q, and let's say this is side R. Then all the sides are in the same ratio. Meaning, if you write A, B, and C over here, then I can put a denominator or basically a ratio symbol over here, and I can put over here P, Q, and R. A by P, excuse me, this by this is equal to this by this is equal to this by this. All the sides are going to be in the same ratio. Okay, all the sides are going to be in the same ratio. And not just that, even the heights are going to be in the same ratio. So by chance, if you mark the height of that particular triangle, okay, by chance if you mark the height of that particular triangle, so the height of that particular triangle, the height of that triangle, height of that triangle ABC will be in the same ratio as compared to the height of that other triangle. So this is that height, this is that height. Okay, so everything is in the same ratio. Height of triangle PQR. Okay, absolutely clear. Okay, everyone, very good. 2027 attendance and lot of 2026 attendance also already here. Great, keep it up guys, clear all your basics. Now that you have understood, okay, some basic properties of the triangle, let's go a little bit further. Let's go a little bit further and let's start defining some important trigonometric ratios you might have studied in 9th or 10th standard for a right angled triangle. So let's say, for example, we have a right angled triangle like so. Let's say this is the side A, let's say this is the side B, and let's say this is the side C, and let's say this is basically 90 degree. Then if this angle is alpha, then this angle, let's say, is beta. First of all, alpha and beta are going to be complementary angles. Complementary angles. When I say the word complementary, it means their sum will be how much? 90 degrees. So alpha plus beta together is going to be always 90 degrees. It makes sense, everyone? So alpha plus beta, which are those other angles apart from 90, will be 90 degrees, their sum. So if this is 30, this will be 60. If this is 10, this will be 80. If this is 20, this will be 70. If this is 35, this will be 55, like that. So their sum should always become 90 degrees. But if you add all the angles of any triangle, let's say for example, this particular triangle, let's say I call this as alpha, this as beta, let's say this as gamma, then always alpha plus beta plus gamma, their sum will always be 180 degrees. The sum of all the internal angles of a triangle will be 180 degrees. You should know this. Okay, fine, sir. I got to know about this. Great. Now, see what are the different trigonometric ratios that we define. For example, we want to write a trigonometric ratio called as sine of alpha. Sine is always opposite by hypotenuse. So if you see opposite to alpha, you have A, hypotenuse is basically C. So sine of alpha will be nothing but A divided by C, which is nothing but the opposite side to the angle upon the hypotenuse. Similarly, if I write cos of alpha, that is adjacent side divided by the hypotenuse. So for alpha, this B is adjacent to it and this is the hypotenuse, so it will be B by C. So it will be nothing but B divided by C. If you talk about the ratio tan of alpha, tan alpha is the opposite side by the adjacent side. That's all. So it is nothing but the opposite side to that angle upon the adjacent side. So the opposite side over here is A and adjacent side is nothing but B. You also have the inverse of these ratios. So sine alpha's inverse, that means 1 upon sine alpha, is basically also called cosec alpha. So cosec alpha is hypotenuse by opposite. Similarly, if you take cos alpha's reciprocal, that is called sec. So that is nothing but sec alpha. So sec alpha is hypotenuse by adjacent. And if you take over here, this is nothing but 1 by cot of alpha. So cot of alpha is adjacent by hypotenuse. Is that absolutely clear? So these are your trigonometric identities or ratios. Sorry, not identities, trigonometric ratios, which you should definitely remember. Guys. Everyone, there is one also interesting formula about tan, which happens to be, let me just put it over here. If I can, no, I don't think I have space. This tan of alpha is also going to be sine of alpha by cos of alpha. And you will see cot of alpha will be cos of alpha divided by sine of alpha. This is also going to be always true. Okay, so I'll just block them off all. Okay, so sine is opposite by hypotenuse, cos is adjacent by hypotenuse, tan is opposite by adjacent, tan is sine by cos also, and the exact reciprocals are cosec for sine, sec for cos, cot for tan. These are things which you should obviously remember. You have studied back in the school level. Is that right? Great. Now, there are some basic trigonometric identities. Now, when I say trigonometric identities, it means they are always going to be true. Trigonometric identities and formulas. Okay, they are always going to be true. For example, what are those first three important identities? So, first is sine square x plus cos square x, or you can also write sine square theta plus cos square theta is always going to be 1. Yes, sine square theta plus cos square theta is always going to be 1. Jerusha, you will get the notes in the PDF form after the session is over, maybe by tomorrow. Okay, it will be there in the comments as a pinned message or even in the description box. All right. Next one, 1 plus tan square theta is nothing but sec square theta. What is the third trigonometric identity? Come on, guys. I want to see how many of you remember it. Yes. How many of you remember it? Yep. 1 plus, instead of tan square, you have cot square theta. And instead of sec, you have cosec. Cosec square theta. These are your three most important identities. Sin square plus cos square is 1. 1 plus tan square is sec square. 1 plus cot square is cosec square. You should definitely know these trigonometric identities. Now let's go to the formulas part on the next page. Okay, these are the basic things. These are the basic things which you should definitely know. Let's talk about the formulas. So first comes your angle addition and subtraction formulas. Angle addition and subtraction formulas. Let's have a look at that. Angle addition and subtraction formulas. Starting off with, if you have sine of angle A plus angle B, then the answer to that will be sine of A into cos of B plus cos of A into sine of B. This is what the answer will be. Sine of A plus B will be sine A cos B plus cos A sine B. But if it is cos of A plus B, then instead of sine cos cos sine, it starts with cos cos and then sine sine, meaning cos A cos B minus, instead of plus there is minus, sine A sine B. This is the formula. This is the formula, my dear students. Okay, keep this in mind. So cos of A plus B, it is cos A cos B minus sine A sine B. Lastly, you have the tangent ratio tan. So tan of A plus B will be nothing but tan of A plus tan of B, whole thing divided by 1 minus, if there is plus, there is minus here, tan of A into tan of B. That's it. Now, everywhere over here, let's say we started with plus. When we start with plus, for sine, sine is same. That is the logic you can remember. For sine ratio, SIGN, the positive negative sign is the same. So, for cos, as you can see, the sign is opposite. For cos, the sign is opposite. If it is plus, there is minus. For tan, in the numerator, the sign is the same, but in the denominator, the sign is opposite. In the denominator, the sign is exactly opposite. So now you can easily guess what would happen if this was a minus sign. If this was a minus sign, here the sign will be same. Minus, minus, plus, plus. For cos, the sign is opposite. So if it is minus, then it is plus. If it is minus, then it is plus. Here also, if it is minus, on the numerator it is the same, but in the denominator it is opposite. So this becomes your complete set of formulas. Everyone, absolutely clear? So these are again very, very important. Don't worry, we'll practice a lot of questions based on these. We'll practice a lot of questions based on these. Very, very important. So from these formulas only, you get the double angle formulas. You basically get the double angle formulas. The double angle formulas. See, initially it might look very crazy for all of you. Sir, so many formulas, sir. Yes, initially it happens. But believe me, write these formulas 10 times and not in order. If you're writing this formula, next formula, don't write this. Next formula, write this. Then next formula, write this. Then next formula, write this. Next formula, write this. Next formula, write this. So randomly challenge yourself mentally. Do you remember the formula? If you write it few days, just few days, I'm telling 10, 20 days, 100% you will remember it. And once you start using it, you will remember it even better. And if you tend to forget it, maybe you have a long break, something, maybe you didn't use it for some reason, then again start practicing a few things, write it and practice. Don't mentally say it. If you mentally say it, it's of no use. Trust me, you will never remember it in the examination. Okay? Try it and test it. I'm telling you. I've been a student. I've seen many students for the last 13 years. So the moment students say, sir, my by-hearting skills, you don't know my biology, sir, my memory skills are very good. I am like, very good. Congrats. I will pat on your back. But when it comes to maths and physics, just remembering, memorizing is of no use. You have to write it and practice it. Okay? Fair enough. So double angle formulas means two times of that angle. So say for example, sine of 2 theta. Now, sine of 2 theta, see what exactly happens. Sine of 2 theta, I can say it is sine of theta plus theta. This is like sine of a plus b. This is like sine of a plus b formula. So what should happen? It should be sine a, here a is theta, cos b, which is cos theta, plus cos a, which is cos theta, into sine theta. Guys, sine theta plus cos theta sine theta is the same thing. So it is nothing but 2 times of sine theta into cos theta. So hence the answer to this exactly becomes 2 times sine theta cos theta. That is the answer for this. Many times you are going to use this, especially in the projectile motion. If you are a 12th standard student, you might vaguely remember in the range formula you use this. Next is cos of 2 theta. Next is cos of 2 theta. How do I deal with it? See guys, cos 2 theta is nothing but cos of theta plus theta. Okay, wait a minute. Cos of theta plus theta is cos of a plus b. Cos a cos b minus sin a sin b. Okay, so this will be cos a cos b, a and b, minus sin a, which is sin theta, and sin b. What is this? This is nothing but cos square theta minus sin square theta. So one of the ways in which you can write this is cos square theta minus sin square theta. This is not the only way to write it. You can further rewrite it in different ways. How? Remember, there was a trigonometric identity just some time back. I told you sine square plus cos square is 1. Sine square plus cos square is nothing but 1. So what if I put sine square theta as 1 minus cos square theta? Is that right? Because how am I able to write it? Because I know sine square theta plus cos square theta is equal to 1. So cos square theta will be 1 minus sine square theta. If I bring that sine square theta over there. And same way, I can also write sine square theta as, similarly, I can also write sine square theta as 1 minus cos square theta. 1 minus cos square theta, which is what I have done over here. So what will happen when I expand it? Cos square theta minus 1, minus minus is plus. So plus cos square theta. Cos square and cos square will become 2 times of cos square theta. So I can also write it as 2 times of cos square theta minus 1. 2 times of cos square theta minus 1. I can also rewrite it as, say for example, instead of cos square, I can write it 1 minus sine square theta. Instead of cos square, I can write 1 minus sine square theta, and this sine square is anyways there. So what will happen? 1 minus sine square and sine square, it will become 2 times of sine square theta. So the other way of writing it is 1 minus 2 times of sine square theta. You can use this or this depending on what is needed for solving that question. Okay, so this is another formula. Last is your tan of 2 theta. You can guess it very easily. Tan theta plus tan theta upon 1 minus tan theta tan theta. So tan theta plus tan theta, tan theta plus tan theta is 2 times of tan theta upon 1 minus, what is this? Tan theta into tan theta is nothing but tan square theta. Tan square theta. So this is also important. These three forms are important, and this is also important. Sir, can I only remember this? Yes. But then In the exam, you might need these conversions. There you might waste extra 15 to 20 seconds. Okay, sir, I will waste that 20-30 seconds. But then remember, there are 180 questions and 180 minutes. So per question, you get a minute. And in physics, you need more than a minute. So you have to sacrifice your bio time for physics. Only then you can cover the physics paper. Sir, it's okay, no, sir, one question only. See, that is what it happens. You start with one question saying, oh, I will take 15-20 seconds. It's okay, I'll derive in the exam. Another concept will come, oh, I will derive it. How many things will you derive? Will you invent some new thing? So you do not have that much time. Remember the results and don't keep your ego. I will derive it. It's okay. I will see. I just know this is important. In the test, this didn't come. No, don't keep those things. In the exam, anything can come from anywhere. Keep that in mind. Okay? Very good. Excellent. Many of you are writing the formulas with me. Very good, guys. Very good. So these are the major formulas which we have learned till now. Okay. Yes. I think now it's a good time that I give you standard angles and their sine and cos and tan. Okay. So let's start with that. So let's start with over here the sine ratio, then the cos ratio, and then the tan ratio. Okay, keep it over here like this. And let me put all the angles one by one. Very important table, guys. Starting off with 0 degree, then 30 degrees, then a new angle which you're going to learn 37 degrees, then 45 degrees, everybody's favorite, and then you have 53 degrees standard angle. Anything else you don't have to remember, okay? Then 60 degrees, another common angle, and then you have 90 degrees, and then you have 180 degrees. These are your standard angles which you need to remember. Okay. So let me create partitions over here. Okay. If you are also making that table with me on your rough sheet or your running notes, that is well and good. But you will also get the notes, but don't just keep it, practice it 100 times. Okay. So let's start. Starting off with sine of 0. Sine 0 is 0. Cos of 0 is 1. Tan of 0, sine by cos is tan. Remember, tan is always, I had told you this before also, that tan is always sine by cos. So just do that, you will quickly get it. 0 by 1, 0 divided by any number is going to be a big fat 0. Now, once you do 0, doing 90 degrees becomes easy. So sine 0 is 0, but sine 90 is 1. It's exactly opposite. And cos 90 is going to be 0. Cos of 90 is going to be 0. 1 divided by 0 is not defined. So do not put anything over here. It is not a number. It is not infinite also, but it is definitely not a number. Okay. 1 divided by 0 is not recommended. It is illegal. Okay. Fine, Jerusha. All the best. Attend the Paul Sir's class. I know you are DNA student. So sine 30, sine of 30 is basically half. Cos 30 is the root 3 divided by 2. When you divide both of them, 2 cancels and you will get 1 divided by root 3. Now doing 60 degrees becomes easy. So my dear students, sine of 60 is basically root 3 divided by 2. Cos 60 is basically half. Tan of 60 is this by this, 2 cancels. You will just get root 3. So tan 60 is root 3. Tan of 30 is 1 by root 3. Okay, tan 30 is less, 1 by root 3. Tan 60 is positive root 3. Doing 180 is the next recommended move. Sine of 180 degrees is 0. Cos of 180 is a negative 1. Very, very important in work power energy chapter. You will be using it for negative work done, etc. Tan, you divide this with this. It doesn't matter. 0 with any number is going to be 0. 0 by negative 1 is also 0. So sine 180 is 0. Cos 180 is negative 1. And tan 0, tan 180 is also 0. Let's go to 45 degrees. Sine 45 is 1 divided by root. And everybody's favorite, this is also 1 by root 2. Cos 45 is 1 by root 2. Cos 45 is 1 by root 2. Say it with me again and again. Whisper it. Say it loud. Doesn't matter who are you with. Say it aloud. Write it. Practice it 100 times. Next, tan. This by this both are same. So the answer will be 1. The answer is 1. Okay? Fair enough. Now for 37 and 53, I'll tell you an easy trick by which you will never ever make a mistake. See, and you will never be even confused. When you have that triangle for, when you have 37 and 53 degrees, then draw a right angled triangle like this with the sides, the smaller side 3, the larger side 4, and the hypotenuse will be 5. And it is obvious that 3 square plus 4 square is 5 square, because 5 square is 25, 3 square is 9, 4 square is 16, 9 plus 16 is 25, Pythagoras triplet. Okay, Pythagoras theorem. Okay. Now, do you see the numbers 5 and 3? The 5 side and the 3 side. So whatever angle is between 5 and 3 happens to be 53 degrees by coincidence. This is purely coincidence. Else somebody will say, sir, 3 and 4 are together. Is this angle 34? No, no, no. Only for 3 and 5, it just happens by coincidence. Only in this scenario, not every time. Then 5 and 4, whatever that remaining angle, how much will it be? The complementary angle, which is 37 degrees, because we all can see 53 degrees plus 37 degrees are complementary. It will be 90 degrees. 53 plus 37 is 90 degrees. Everyone? Okay. Is this essential to watch all the basics class? Please respond to the message, sir. Humble request. Vanita, if you are good with trigonometry, if you remember, then no need. But I have forgotten, sir. Sir, every time a trigonometric question comes, I'm getting stuck in some part. So maybe that particular part you can watch. But if you are completely blank, you have forgotten, and you have a lot of backlogs, then I would recommend to watch all the basics class. Otherwise, it is not needed. Okay? I hope I have cleared your doubt. All right. Okay, sir, I understood till here, sir. So now what are you trying to say? How can we figure out these angles? See, sine 37, sine of 37. 37 means what? This angle, opposite by hypotenuse, 3 by 5. Directly you can put 3 by 5 over here. Cos 37, cos 37 is adjacent by hypotenuse. So it will be nothing but 4 divided by 5. Tan of 37, tan is opposite, which is 3, by adjacent, which is 4. So 3 by 4. Hence, the answer will be 3 divided by 4 over here. Is this clear? Very easy to figure out sine, cos, tan, everything once you know this magic triangle which I have given you. So 3, 4, 5, very simple. After 3, which comes 4? After 4, what comes 5? And 5 and 3, the sides, whatever is that internal angle is 53. If this is 53, the other angle will be 37. Just draw that triangle in a rough sheet and you will be able to get it. Okay? All right. Now 53. Let's come to that. Sine of 53 degrees. Sine of 53. 53 is this. So opposite by hypotenuse. So 4 by 5. So this will be 4 by 5. Next, cos of 53. Cos of 53 adjacent by hypotenuse. So 3 by 5. So this will be 3 by 5. Lastly, tan of 53, guys. Tan of 53 opposite by adjacent, 4 by 3. Hence, the answer should be over here, 4 by 3. So, if you remember this table, not by heart, but by logic. Sir, I have done it 100 times. Okay, sir, now I'm able to remember it. That's it, guys. You will be able to solve many questions. Okay? Very good. I'm so glad. Thank you so much, Vanita. And Rathal, see, it's a very simple difference, man. See, some students prefer self-study. Maybe they have already enrolled in a coaching, or maybe they need some clarity, or maybe, you do not have that money to afford any batch. Sir, I'm very sincere. Or maybe you already spent and you need that extra support in all the topics, then obviously YouTube classes are the best. Number two, sir, I don't have any batch. Sir, I am not able to just do self-study. I'm watching the classes, but I need more. Then a batch is highly recommended because you get personal guidance, you get regular tests, you have DPPs, you have assignments, you have modules, you have mentorship, you have analysis, you have proper schedule, you maintain that system. Plus, when you pay for a batch, you automatically develop that rhythm, that momentum, and you sense that competition and improve. So that's when that batch is recommended. Is that clear? I hope I have answered your question. Okay. Fine, sir. I have done all these things. Sir, let's begin with some questions, sir. Okay, let's begin then. Here comes the questions part. Okay. Everybody is going to love this. Everybody is going to love this. So let's start one by one. If sine theta is equal to 2 by 5, find cos theta. Come on, let's do this. If sine theta is 2 by 5, find the value of cosine of theta. Okay. Think, is there a formula which relates sine theta and cos theta? Yes, there is. Sine square plus cos square is 1. Okay, fine, sir. So let's do this. Sine square theta plus cos square theta is equal to 1, sir. So sine theta is already given as 2 by 5. So sine square means 2 by 5 square. Oops. Plus cos square theta is 1. So therefore, cos square theta is equal to 1 minus this guy, which is 2 by 5 the whole square. So this is 1 minus 2 square is 4. 5 square is 25. Perfect. So taking the LCM, this will be 25 minus 4 by 25. All right. 25 minus 4 is 21, and this is divided by 25. So that is cos square theta, but I want cos theta. So cos theta will be root of 21 by 25. Therefore, in the final step, cos theta will be root of 21. Root 25 is 5. So that is the answer. Everyone with me? Yes. Hi, H. Yes, Tirtheshwaran, perfect. Amazing, amazing. Let's do the next question on your screen. If cos theta is 3 by 7, find the value of tan theta. If cos theta is 3 by 7, find the value of tan theta. Okay. Now this, is there a direct formula for cos theta and tan theta? Well, I don't think so. Directly it is not there. So one way of doing this question will be thinking for tan theta, the formula is 1 plus tan square theta is the sec square theta. That formula is there, if you remember. Yes. So 1 plus tan square theta is sec square theta. That formula is there. Sir, but sec I don't know. Oh, don't worry. From cos you can find sec. How? See, simple. Cos theta is basically 1 by sec of theta. Everybody knows this. Or you can also write the opposite. Sec of theta is 1 by cos of theta. So what is that cos theta? So this part I have given it to you over here only. Just let's go back. Yeah. Sec and cos, they are reciprocals of each other, right? Sec and cos are reciprocals of each other, and 1 plus tan square is sec square. That is also given to you. Okay, perfecto. So what we can do? We can put cos theta, which is basically 3 by 7. So it will become basically 7 by 3 is nothing but sec of theta. Perfect. So let me put sec theta as 7 by 3, but this is whole square. And this is 1 plus tan square theta. Okay. So therefore tan square theta will be 7 by 3 whole square. Oh my God. 7 by 3 whole square minus 1. 7 square is 49. 3 square is 9. So minus 1. So it will be 49 minus 9. Something is happening. 49 minus 9 divided by 9. So that is basically 40 divided by 9. But what is that? That is tan square theta. So what will be tan of theta? It will be root of 40 by 9. So therefore, the value of tan theta will be root of 40. Root of 9 is 3. If you want, you can write 40 as 4 into 10. You can also write 40 as 4 into 10 divided by 3. So root of 4 is 2. So 2 by 3 will be there, root of 10. So that is the answer, 2 root 10 by 3. 2 root of 10 divided by 3. Very good, Hayed. Very good. Proud of you. You are answering very quickly. Amazing. Amazing. Yes, Tirtheshwara. Amazing, my dear. Next question. Let's go ahead. Next question. Let's go ahead. So we have done some nice questions over here. Let's go ahead, guys. Let's go ahead. If the base of a right angled triangle is 8 units and makes 53 degrees with the hypotenuse. Question is, find the hypotenuse, the height, and the area of the triangle. Find the hypotenuse, the height, as well as the area of the triangle. Very nice question. Let's try to solve this. First of all, let's assume a right angle triangle like so. Okay. This is our right angle triangle. This is the base. Let's say I call that base as B, and that is making an angle of 53 degrees with the hypotenuse, which I call it as C. So I can call the height as A. So this is the height of that right angle triangle, which is, let's say, A. So ABC becomes the triangle. So if this is the right angle, it is obvious that this angle, how much should it be? Come on, guys. So this is the question's representation. So if you think about it carefully, you will understand this angle should be 37 degrees. This should be nothing but 37 degrees. Everyone till this point absolutely clear? Okay. Yeah. So now if I know the base, can I find the height? Yes, if I know the angle, and I can also find the hypotenuse if I know the angle. So from base and hypotenuse, the best ratio that I can think of is cos of 53, because cos of 53 is nothing but adjacent divided by hypotenuse. What is the adjacent side? It is that base. And how much is that base given? The base is given as 8 units. So why not put the adjacent side, which is nothing but the base in this case, which will be nothing but 8 units divided by the hypotenuse. What is cos 53? Cos 53, guys, I had told you, use this triangle. If it is there in your rough sheet, it will always be helpful. Yeah, cos 53. It is 3 by 5. Adjacent by hypotenuse. It is 3 by 5. You can see that. Cos of 53 is 3 by 5. Perfect. So use that over here. So cos 53 is 3 by 5. Okay. Yes, sir. So from this, the hypotenuse will be, check this out, 8 will stay as it is, 5 will go on the top and divided by 3. So therefore, the hypotenuse, 8 5s are 40, so 40 by 3. That is the answer. So hypotenuse is done. Can I find the height? Yes, we can again use the trigonometric ratio of tan theta. That will be helpful over here. So if I use tan of 53 degrees, which is opposite by adjacent, in this case the adjacent is nothing but the base, the opposite side is basically A, the base is nothing but 8. What is tan of 53? Go back to that triangle. Tan 53 opposite by adjacent, so 4 by 3, so it is nothing but 4 divided by 3. So 4 divided by 3. So that magic triangle always is going to help me. So basically that A will be nothing but 4 into 8 divided by 3. Therefore, A will be 8 fours are 32. So 32 divided by 3. 32 divided by 3. Everyone with me on this? All right. Last one is the area of the triangle. So the area is half into the base multiplied by the height, which is 8. Height, which is basically 8. So what is the base? Base is basically 8. What is the height? Height is basically 32 divided by 3. 8 by 2 is nothing but 4. So 4 into 32, the whole thing divided by 3. Is that right? So what would the area come out to be, guys? Check this out. 34 are 120, 2 4s are 8. So 128 by 3. So 128 divided by 3 square units. That is the answer. 128 divided by 3. Perfect, everyone. I'm so glad when you are able to understand and watch it. So I'm pretty sure you will be one step ahead of your batchmates by next year. And maybe you will spend the 12th standard just in the revision. That would be great. Okay. So this was another question. Now, everybody wondering, sir, will they ask this question in NEET? See, this will be a part of a big problem. So you can understand the length of the problem. So maybe somewhere in magnetic flux, area needs to be calculated. Maybe a triangular loop is given. So there, to calculate the area, you need to use trigonometry. Maybe in some kinematics question, something is there. Somewhere you are using cos theta and you need suddenly the value of tan theta in a big problem. So this has to be done immediately. Maybe in some another question, sine is given, you need to find cos. So all these things will be a part of a bigger problem. Got it? So this is not the big problem. This is a small problem or a small part of a big question. Okay, we're just seeing a small thing. Like there is a big operation, then there is one attendant who will come and probably just do the stitches or maybe just give the, some tool. So that is what we are doing right now. So to go to the big operation, you should know everything step by step. Perfect, perfect. So let's go ahead. Let's go ahead to the next kind of question, and here it comes. Can we figure out what might be sine of 120 degrees? Now you might be like, sir, sine 120, I don't know, sir. Sine 60, I know, 30, I know, 90, I know. So maybe I might have to use some of the formulas which I just gave it to you over here. And most likely, how about this double angle formula? How about this double angle formula? Hey, oh, you are a PCMC student. Wow, great, man. Amazing. So I'm guessing you were also on the Vedantu MSTCT channel and you are also over here following me through MSTCT JEE NEET. Welcome. And next time I come to the PCMC center in Pune, do meet me. Okay, great. So I think we can use this double angle formula maybe somehow. Maybe we can use double angle formula somehow. Yeah. So maybe that might help because I feel sine of 120 is nothing but sine of 2 multiplied by 60. Oh, it's a double angle formula. Sine of 2 theta. Sine of 2 theta is nothing but 2 sine theta into cos theta. That is the formula. Sine 2 theta is 2 sine theta cos theta. Is that right? Okay. Yes. Yes. You can see that right over here. Sine 2 theta is 2 sine theta cos of theta. Oh, perfecto, sir. This is so cool. So what now? What now? Check this out. This will be sine 60 is the root 3 by 2. What is cos of 60? That is nothing but half. 2 and 2 cancels. So only root 3 by 2 remains. So sine of 120 is nothing but root 3 by 2. Wow, sir, this is so cool. I got it. Sir, let's do one more problem. Okay, fine. Here I go with another question. Can we find cos of 106 degrees? Okay, can we find cos of 106 degrees? Think, is there some formula which we can use? 106. Oh, wait a minute. If I divide it by 2, I get 53 degrees, and 53 degrees is a standard angle. I just know 53 degrees. We have seen it over here. It's a standard angle. I know sine, cos, tan. Oh, so why not write it as cos of 2 times of 53 degrees? Now you can see I can use the double angle formula for cos, which I have already given to you. But there are multiple ways of doing it. I can do it as cos square minus sine square, or 2 cos square minus 1, or 1 minus 2 sine square. I will prefer either this or this. Why? Because if I use the first formula, I have to find cos also, sine also. Why break my head on finding two things? I'll find either sine or cos. So either use this or use this. Getting my point? Why I'm sticking to any one of them? So let's go back and let's use, let's say, 2 cos square minus 1. Let's use basically 2 times of cos square minus 1, cos square of 53 degrees. But what the hell is 53 degrees cos? Cos 53. Let's go back. Don't go to this table. See, a lot of students while solving problem, you know what they do? They'll go to this table. Ha, sir, cos 53, sir, it is 3 by 5. Don't do that. See, that is where you are making mistakes in solving problem. Because in the exam, who will give you the table? But in your rough work, you will be able to draw this triangle. So think how you will solve in the exam. Exactly solve it that way. Exactly solve it that way. Yes, cos 53. Cos 53 is adjacent by hypotenuse. So 3 by 5. It is nothing but 3 by 5. So let's go over here. Cos 53 is basically nothing but 3 divided by 5. But this is whole square and this is minus 1. So this will be nothing but 2 multiplied by 3 square is 9. 5 square is 25 minus 1. 9 2s are 18 minus 25. The whole thing divided by 25. So 25 minus 18 is 7. So 18 minus 25 is minus 7. So minus 7 by 25. That is the answer for cos of 106 degrees. Beautiful? Yeah. NEET math is hard. Oh, is it? Venom. Well, don't worry. You are safe if you have not seen JEE math, and because you are right now in 10th standard, you have not seen 11th and 12th standard maths, so you are safe. But one advice to all the NEET aspirants, please take mathematics as a subject in 11th and 12th standard. Okay, if your 10th, 11th doesn't matter. If you have the option, please take it. Don't think, sir, let me get rid of math. No, why use that maths? That is one of the biggest mistakes which a NEET aspirants does in their 10th moving 11th era. Okay, because you feel that maths will not come, but actually maths is there in plenty of amount. Okay, and when you have maths as a subject, you will study it, and then the NEET physics looks very easy. In fact, many of the NEET toppers, you will see that they would have taken PCMB. Yeah, that is one hidden truth. All right, fine, sir. What about, what about, let's say, sine of 15 degree? Like, what? Sir, 15 degrees sine? How do you expect me to find this? Maybe it is not a double angle, but maybe you can find it by subtraction or addition. Yeah. Bhuvan, oh my God, you also are PCMC student. What is this? Everybody from PCMC is here or what? Wow, so cool. Then I would love to have all the students out here then. Okay. So sine of 15 degrees. How do I do it? Sir, 45 minus 30 is 15, sir. Oh, correct, correct, correct. We can do that. Sir, sine of 15 is 45 minus, sorry, 45 minus 30. Okay, amazing. So this is sine of A minus B formula. Sine of A minus B formula. So sine of A minus B formula, I already told you. Sine of A minus B is sine A cos B minus cos A sine B. In sine, sine is same. SIGN, positive, negative, sine is same. Okay, so sine cos, cos sine. So it will be sine 45 cos 30 cos 45 sine 30, but do not forget the minus sign. What is sine 45? 1 by root 2. Cos 30, root 3 by 2. Cos 45, 1 by root 2. Sine 30 is 1 by 2. Okay, 1 by 2 root 2 is common. I can see 2 root 2 is common. On the top, I have root 3 and over there I have 1. So I think that is the answer. So root 3 minus 1 upon 2 root 2, that's the maximum I can simplify for sine of 15 degrees. Is this absolutely clear, everyone? Perfecto? Okay. Let's do one last question before going to the next set of questions or next type of problems. Everyone with me? Okay, let's do tan of 75 degrees. Tan of 75 degrees. Think. Is it double angle? No. Can I get it by addition or subtraction? Yes. How? 30 and 45. 30 and 45, you add them, you will get 75 degrees. So why not write it as tan of 45 degrees plus 30 degrees. Perfect. And we know tan of A plus B formula. Let's go. Where is it? Tan of A plus B formula. Tan of A plus tan of B upon 1 minus tan A tan B. 1 minus tan A tan B. That is the formula. Okay, sir. So let's write down tan of 45 plus tan of 30 whole thing divided by 1 minus tan 45 tan 30. Okay. So what is tan 45? 1 by, oh sorry, it is just 1. Tan 45 is just 1. Tan 30 is 1 by root 3. Leave that numerator now. 1 minus. Tan 45 is just 1. Tan 30 is again 1 by root 3. Sorry, this was plus, my bad. Yeah. So what do we do? Take LCMs in the numerator and denominators. So it will be root 3 plus 1 by root 3. This is the numerator. So root 3 was common. So root 3 plus 1. And here you will have root 3 minus 1 by root 3. What is happening over here? Root 3 and root 3 will cancel, of course. Root 3 and root 3 will cancel. So you'll have root 3 plus 1 upon root 3 minus 1. This is one way of solving it and leaving the answer. But if you want, you can rationalize it if you want and see the options. So if you try to rationalize it, it will look something like this. So you will have to multiply the denominator and numerator with the opposite of this, which is the root 3 plus 1. So we'll multiply it by root 3 plus 1, numerator and denominator. So this is a plus b whole square. Yeah, this is a plus b whole square. So it will be a square, which is root 3 square, plus b square, which is 1 square, plus 2ab. So 2 root 3 multiplied by 1. That is your numerator. Denominator, this is a plus b and a minus b. So it will become a square minus b square. So it will become root 3 square minus 1 square. So what will this be? Root 3 square is 3 plus 1 square is 1 plus 2 root 3 whole thing divided by root 3 square is basically 3 minus 1. So that is what you will get. So solving it further, 3 plus 1 is 4. So it will become 4 plus 2 root 3 whole thing divided by 3 minus 1 is 2. 3 minus 1 is 2. But you can further divide 4 with 2, it will become 2. And 2 with 2 is 1. So 2 plus root 3. So 2 plus root 3 can also be the final answer. Is that clear, everyone? Absolutely. So this is how you can solve for tan 75 degrees, just in case it is asked or needed in the question. Okay, sir, I understood all this. Sir, but I have a question. Sir, every time the angle is bigger than 90 degrees, shall I always use these methods? Or is there a shortcut trick? Can you teach me? Well, there is a shortcut trick which I am going to teach you. I'm going to teach you a very nice shortcut trick which will help you in all the questions. What is that shortcut trick, sir? Here it is. First thing, let me explain to you the quadrant system. If this is x-axis, this is y-axis, this is negative x, this is negative y. This is your first quadrant. There are 4 divisions which you can make. First quadrant, this is quad is 4, so 4 divisions. So quadrant is a division. So this is the first division. This is the second quadrant. This is the third quadrant. And this is basically your fourth quadrant. This is basically your fourth quadrant. Every angle always has to be measured with respect to always has to be measured with respect to this horizontal line going towards the right hand side in the anti-clockwise way. In the anti-clockwise way only. Meaning, let's say, I'm not able to get this here. Yeah. So this is basically the reference line, it is called. This is the reference. And always remember anti-clockwise angles. So this is anti-clock. Clock goes like this. So anti-clock is the other way around, is considered as the positive. So if at all you take a point here and tell me, sir, if I draw a line like this to this particular point, sir, that angle, sir, yes, this will be the angle. And most likely the angle will be like 30 degrees, 40 degrees, something like that. So, it will be somewhere between 0 and 90 degrees. Once you reach over here, this angle will be 90 degrees because you go 0, 1, 2, 3, 4, like that, 70 degrees, 80 degrees, and you reach 90 degrees. You continue your journey beyond 90, it will become 100, 120, 130, 140, 150, and you will reach here. This angle over here will be 180 degrees. This angle will be 180 degrees. So if you ever had a point in somewhere over here, then the angle that you will be measuring will be this whole angle. This complete angle will be the angle that you will be measuring. This will be in the second quadrant, which is between 90 and 180 degrees. Okay, sir. Then next one, guys. Okay, observe this. Let's say, for example, we take a point over here. Then I will be measuring the angle basically like this. This will be in the third quadrant. If this is 180, slowly if you go further, how much will this angle be? 180 plus 90 degrees, that will be 270 degrees. That will be 270 degrees. Everyone clear? And finally, let's say, sir, what if I'm here, sir? Okay, if you are somewhere over here, you are in the fourth quadrant. Anywhere in this space is the fourth quadrant. But then you have to measure this much angle as your angle, which will be in the fourth quadrant. It will be between 270 degrees. And when you come back over here, it will become 360 degrees. You start with 0. And when you come back, you will overlap on the same point at 360. Again, if you do one more revolution, 360 will become 720 and so on and so forth. Is this absolutely clear, my dear students? Everyone till this point? Everyone till this point absolutely clear? Yep. Perfecto. Very good. So, these are your quadrant systems of measuring the angles. Anti-clockwise is positive. Right hand horizontal line is taken as a reference. With respect to that reference, every angle is being measured. So, quickly tell me in the chat box, 210 degrees, which quadrant will it lie? 210 degrees. 210, it is before 270, but after 180. So 100% third quadrant. Think, sir, which angle is 120 degrees in? 120, after 90, but before 180. So second quadrant. 15 degrees, it's before 90, so first quadrant. 300 degrees, it's after 270, but before 360. So 300 degrees will be fourth quadrant. Got it? So 280 degrees. 280 degrees is after 270, so it should be fourth quadrant. 190 degrees. 190 degrees is after 180, so it should be third quadrant. So you should be immediately be able to guess which quadrant it lies in. Which quadrant does any particular angle lie in? Okay. So this much, sir, I understand, sir. So what next, sir? So this is 0 degree. This is 90 degree. This is 180 degree. This is 270 degree. Okay. Now, keep this in mind that there is a rule called as all silver tea cups. All silver tea cups. Here A, here S, here T, and here C. And you have to go from the first quadrant to the second quadrant to the third quadrant to the fourth. So this is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Meaning, when you are in the first quadrant, all means literally all, be it sine, be it cos, or be it tan, all of them are going to be positive. All of them are going to be positive. Here, all silver teacups, silver, S for sign, only sign is positive. Automatically, our cos and tan, both of them will be negative. S for sign. Next, third quadrant is T. T for tan. So only tan ratio is positive. Automatically other things like sine and cos, both of them will be negative. Lastly, you come back to fourth quadrant over here. C for cos, C for cups. So cos is going to be positive over here. Automatically sine and tan, both of them will be negative. This is called as the ASTC rule, or all silver teacups rule, or the sign rules for the quadrants. Is this clear? ASTC. Repeat after me. All means literally everything. Sine, cos, tan are positive in the first quadrant. S for sine, second quadrant. Only sine is positive. T. T for tan. Only tan is positive in the third quadrant. Cos, cups, fourth quadrant. Only cos is positive in the fourth quadrant. So if I quickly ask you to guess, the sign of each of these things, let's see whether you can do it. Cos 200, positive, negative. Sine 50, tan 300, cos 320, sine 160, tan 150, cos 150, sine 280, and let's say tan, I don't know, something like 240. Okay. Chumma, I have taken some random angles and everything. I want to figure out whether it is positive or negative. That's all. Okay. First thing, which quadrant each of these angles are. 200 degrees. Quickly think, guys, which quadrant does it come into? First, second, third, or fourth? Similarly, think for 50, 300, everything. 200 is less than 270, but it is more than 180. So it is third quadrant. This is basically first quadrant. 300 is more than 270. So last quadrant, fourth quadrant. This is basically 320, fourth quadrant. 160, it's in the second quadrant, isn't it? Then 150, it is basically in the second quadrant. Is that right? Yes, perfect. 150, second quadrant. 280, guys, it's more than 270, so it is in the fourth quadrant. This 240, it's less than 270 but more than 180, so it is in the third quadrant. So once you know the quadrants, it becomes very, very easy. Okay. All right, everyone. So let's start putting up the signs immediately now. So cos in the third quadrant, all silver T, only tan is positive. So 100% this will be negative. In the third quadrant, cos is negative. Only tan is positive. Sine 50, is going to be positive because it is in the first quadrant. In the first quadrant, literally everything is positive. Next, tan 300, fourth quadrant, C, only C is positive, tan is negative, guys. So 100% this will be negative in value. 320, fourth quadrant cos is positive. Fourth quadrant cos is positive. Yes. 160, second quadrant sine. In the second quadrant, sign is positive. In the second quadrant, sign is positive. Perfect. So we'll just put positive over here. 152nd quadrant, all silver. Only sign is positive, rest everything is negative. So this is negative. Is that right? Then going over here, in the second quadrant, all silver. Sign is positive, rest everything is negative. So this is also negative. Sine 280, 280 degrees. Fourth quadrant, only cos is positive, rest everything is negative. So this is also negative. Tan 240, all silver T. T tangent is positive. So this is going to be positive. So at least you should be able to get which one is positive, which one is negative by just looking at the angle and what trigonometric ratio we are talking about. Whether it is sine, cos, tan, etc. Is this clear? This is your ASTC rule. This is your ASTC rule. Okay. Now, okay, sir, but you did not tell me how to find the angles of the big things, the ratio. You're just telling me the sign. What is the value, sir? What is the value, sir? Tell me the value. Okay, I'll tell you the value. See, if you write the angle in addition or subtraction, to this line. So sine 90 plus theta, sine 90 minus theta, cos 90 plus theta, cos 90 minus theta, tan 270 plus theta, tan 270 minus theta, like that. Then if it is sine, convert it into cos. If it is cos, convert it into basically sine. And if it is tan, convert it into cot. And if it is cot, convert it into tan. Basically, I did not have to put it, okay, this way. Sine becomes cos, tan becomes cot becomes tan, cos becomes sine. So flip the ratio only. You will understand when I solve the question. But whenever you measure the angles with respect to 0 degrees or 180, sine 30, which is 0 plus 30, or cos, 0 plus 50 degrees, or cos 180 plus theta, tan 180 minus theta, cos 180 plus theta, sine 180 minus theta. So those kind of things. Then whatever is the ratio remains as it is. Meaning, if it is sine, keep it as sine only. If it is cos, keep it as cos only. If it is tan, keep it as tan only. If it is cot, keep it as cot only. That's it. Nothing changes. So no change over here. So no change over here, but here 100% there is a change. So I'll tell you how to exactly solve a question based on this particular rule. See, observe. For example, we have to find cos of 150 degrees. So first thing, can I write cos 150 in terms of something plus something? Basically 0, 180, 270, those numbers. 0, 180, 90, 270, those numbers. I think 150 is closest to 180 degrees. So can I write that as cos of 180 minus 30 degrees? 180 minus 30 degrees. Everybody agrees to this point? Yeah, everybody agrees to this point. It is nothing but cos of 180 minus 30. Okay. Now, before going ahead, just think 150 degrees. That 150 was in which quadrant? 150 was in which quadrant? It was basically in the second quadrant. It was in the second quadrant, isn't it? It was in the second quadrant, and in the second quadrant, cos is, what is the value of cos? It's all silver. Sine is positive, everything else is negative. So in the second quadrant, it is 100% negative. So whatever happens ahead, the answer must be a negative value. It must be a negative value. Okay, fine. Now, when you write it as 180 plus minus 30, 270 plus minus 30, 90 plus minus 30, forget that numbers like 90, 270, 180, etc. Just ignore this. Ignore this completely. ignore this completely and only consider this angle. Don't even take that minus sign. Just bring it as it is. Just bring it as it is. So it will be basically 30 degrees. And because you are measuring it with respect to 180, what did I tell? When you are measuring it with respect to 0 or 180, this line, sine remains sine, cos remains cos, tan remains tan. So that means this cos must remain as cos only. It remains as cos. It remains as cos, remains as cos because of that 180 degrees. If this was 90, then this cos would have become sine. This sine, if it was there, it would have become cos. That's all. So it will be minus cos 30, my dear students. That's the answer. And what is the value of cos 30? It is root 3 by 2. So the answer is minus root 3 by 2. That's it. Okay. So you need to know step by step which part leads to where. Identify the angle, which quadrant. You will understand the sign. See where is it closest to. Then express it as that 0, 180, 270, 90 plus minus something. That plus minus something afterwards, that theta which is there will come as it is. If this is cos, it will become cos or sine, depends on what are you adding or subtracting it with. If it is 0 or 180, it will remain as it is. But if it was 270 or 90 degrees, then sine will become cos, cos will become sine. So say for example, the same question, I could have also solved it like this. For example, cos of 150 degrees is, imagine, I can write it as cos of 90 plus 60 degrees. There is no harm in that, isn't it? And because it is in the second quadrant, I know for a fact the answer will be negative. Because this is in the second quadrant, sorry, it will be negative. Yeah, so it will be negative. So minus sign is there. Now, what did I tell? That forget this 90 plus something, ignore it. Just whatever that angle is there remaining, just take it as it is. So I'll put 60 degrees. It is measured with respect to 90. 90 is over here, vertical line. So you should change it. Sine will become cos, cos will become sine. So since it is cos, make it as sine. So cos has transformed, it has changed. And why did it change? Because of that 90 degrees. If it was 180, it will not change. Because it is 90, it has changed. So what is sine 60? Sine 60 is root 3 by 2. Whether you do it like this or like this, the answer will remain the same. The answer will remain the same. Is this absolutely clear? How to do this? Let's do questions now so that you will get enough practice. So that you will get basically enough practice. So let's start. Let's find out the tan of 225 degrees. Tan of 225 degrees. Now 225, you will be like, oh my god, what the hell? 225 is more than 180, of course. So if I write it as tan of 180 degrees plus something, what will be that plus something? Think about it. 225 minus 180 is 45. So this will be nothing but 45 degrees. Oh, yes, sir. Perfect. Now, next thing, whatever this angle is there should come over here as it is. Whether the tan will become cos or tan or whatever, that depends on this angle. It is 180 plus something. 180 is horizontal line, nothing changes, no change. Only when you measure it with 90 and 270, you should change. So there is no change. So tan will remain tan. Last thing, 225 is the third quadrant, all silver T. T is positive. So the answer should be positive. That's it. So tan 45 is 1. So the answer is just 1. Is this absolutely clear how we figured it out? Why was it positive? Because this angle was in the third quadrant. The third quadrant, tan is positive. That's all. There you go. Okay. Next, let's take another example. Let's try to find the value of sine of 127 degrees. 127 degrees. Like 127, sir. 127 is pretty much close to 90. So why not write it as sine of 90 plus 37? Wow. 37 is a standard angle, guys. So that will help me. Next thing, 127, you are in the second quadrant. In the second quadrant, sign is going to be positive. So 100% the answer will be positive in nature. 37, bring it as it is. Because it is 90. Because it is 90, what will happen? Sine will become cos, cos will become sine. So since it is sine, sine should be changed to cos. Understood why the transformation happens? Now what is cos 37? Go back to our magic triangle. Go back to our magic triangle. Cos of 37. Cos 37 adjacent by hypotenuse. So 4 by 5 should be the answer. So let's go back. So cos 37 will be nothing but 4 divided by 5. So hence this is the answer of sine of 127 degrees. Okay. Yes. Bhuvan, right now I'm in Bengaluru. All right. Let's go to the next question coming up on your screen. Let's say we have to find tan of 300 degrees. Okay, tan of 300 degrees. Come on, my dear students, let's see if you guys can figure it out. 300 is very close to 270 degrees. So can I write it as tan of 270 degrees plus 30 degrees? Okay, perfect, sir. So 30 degrees, bring it down as it is. As it is. Now think logically, 300 degrees is in which quadrant? It's after 270. So 0, 90, 180, 270 and 360. So it is somewhere in this last quadrant, which is your fourth quadrant. And in the fourth quadrant, cos is positive, all silver teacups. So tan will be negative. So 100% the answer must be negative value. Okay. So 270. Because you are measuring it with respect to the line which is vertical, 270, 90, 270, tan should become cot or cot should become tan. So tan will become cot. So cot 30. But what is cot 30? Cot 30 is 1 by tan 30. Cot 30 is 1 by tan 30. And what is tan 30? Tan 30 is 1 by root 3. So root 3 goes on the top. So the answer will be negative root 3. So tan 300 is negative root 3. Everyone? Absolutely clear? Okay. So this is how you can solve these questions. You've solved many nice questions based on how to find these angles and the sines and cos and whatever. Okay. One last question, but this will be your homework question before we go to the next part. Okay. This is your homework question. Can you find out the value of cos of 120 degrees? Okay. So this is your homework. This is your homework question. Where will you put the answer? The answer should be in the comment section. Answer should be in the comment section. Okay. Answer should be in the comment section. So that is your homework question. I'll put it at the end. Okay. Now, last few things before we wind up trigonometry. We have done many things like addition formulas, subtraction formulas, double angle formulas, finding the sine and cos of everything. Okay. Super clear. Okay. Very good. Now there is another measurement of angle and that is called radian. We will talk about it. Okay. So like you have kilometers per hour and meters per second, millimeters per minute. So different units are there. So there are two different units of angles that you use. So you should know this as a matter of fact. So starting off with 0 degrees, then 90 degrees, then 180 degrees, and then 270 degrees. So one of the unit which you use with the degree, theta degrees. So this is basically your degree unit, degree unit, degree unit. The other unit that is there, theta, like this. This is called as the radian unit. Radian unit. What is this called? This is called as the radian unit. Okay, sir. Radian unit. Fine. So 0 degree is 0 radian. 0 radian. or you can also put 0 like this, that C symbol, one and the same thing. 180 degrees is basically pi radian, or you can also put pi with that half circle which looks like that C. Okay, pi radian is 180 degrees. So if 180 degrees is pi radian, can you quickly guess what is 90 degrees? 90 is half of 180. So if this is pi, half of that will be pi by 2 radian. So this is pi by 2 radian. Wow. So every quadrant is 90 degree, which is pi by 2. So pi by 2, pi by 2, pi by 2. So if you measure this whole angle, 3 times pi by 2 is there. So 270 degrees is 3 pi by 2 radian. 3 pi by 2 radian. Pi by 2, pi by 2, pi by 2. So 3 pi by 2, because everything is 90 degrees, which is pi by 2. If you come back again, over here, then it will be obviously 360 degrees. So 360 degrees, you can think, is multiple of 180, 2 times. 2 times 180 is 360. So 2 times of pi, that is 2 pi of a radian. That's it. So the main funda is that pi radian is nothing but essentially 180 degrees. If you know this, you are sorted. Pi radian is 180 degrees. So pi radian means roughly 3.14 radian is equal to 180 degrees. So that is the conversion factor. 3.14 in radians is 180 in degrees. That is the factor. So can we convert into each other easily? Yes. Yeah. So what's my rank in competitive exam? So Bhuvan, when I wrote my JEE exam and I cleared my JEE advance, my rank was 3,900, and chemistry was very tough for me, unfortunately. Otherwise, I wish I would have got a better rank. My physics was very strong. I scored almost full marks in the physics paper. Okay. So that was JEE advanced. That time it was called JEE mains, which was subjective. No objective questions. We had to write explanation and solve the problem step by step. If our steps are wrong, even if the answer is correct, they used to give us wrong answers. So that is the kind of exam I wrote. Okay. So your Shreyas teacher is the GOAT of physics on YouTube. All right. And especially coming from Pune, Maharashtra, right? So you should take the full advantage whenever I come there to, meet, learn, and interact, and probably take any kind of guidance that you might need. Okay, so how do I convert this? How do I convert this, my dear students? See, if I'm generally given in degrees, if I want to convert into radians, so if theta is in, if theta is in degrees, I want to convert it into radians. What you will do, you will multiply that theta, with pi and divide it by 180. Because 180 is in degrees, degree cancel, radian will remain. So the answer that you will get will be theta in radian. The answer that you will get will be theta in radian. So this is a very easy formula which you can remember. Okay, if it is in degree you want to cancel, so divide by degree, multiply by radian. So pi radian, 180 degree, cancel, you will get it in radian. Very easy. So let's take a few examples just to see whether you are able to convert quickly, guys. Okay, so 60 degrees is how many radian? 45 degrees is how many radian? 30 degrees is how many radian? 150 degrees is how many radian? 120 degrees is how many radian? 135 degrees is how many radian? 225 degrees is how many radian? 300 degrees is how many radians? So let's see whether quickly you can convert it. Starting off with the first one, 60 degrees. Let's do the math quickly. So what you will do? 60 degrees multiplied by pi divided by 180. Everywhere, guys. 45 multiplied by pi divided by 180. 30 multiplied by pi divided by 180. Here 135 multiply by pi divided by 180. 120 pi by 180. 150 pi by 180. Everywhere same formula. 225 pi by 180. 300 pi by 180. Come on, see what is it that you are getting in every case. First answer, 60 degrees. How much will it be? 60 goes with 180 three times, so it should be pi by 3 radian. Pi by 3 radian, everyone. 45 goes with 184 times, so this should be pi by 4 radian. This should be pi by 4 radian, everyone with me. Very good, awesomeness. 30 30 degree, 30 goes with 186 times, so this should be pi by 6 of a radian. This should be pi by 6 of a radian. 150 and 180, 0 goes divided by 3, it becomes 5. This becomes 6, so it will become 5 pi by 6 of a radian. 5 pi by 6 of a radian. This 0 goes divided by 3, it becomes 4, or divided by 6, I believe. So it should be 2, and this should be pi, and this should be 3, because 6 goes with 18 3 times, and 6 goes with 12 2 times. Easy math. So 2 pi by 3 radian. This one, I mean, see guys, you can do it one more way. See, 45 degrees is pi by 4. 45, 45, 45. 3 times 45 is 135. Is that right? So 135 is also 3 times of 45 degrees. Yeah, simple math. So 3 times of this guy. So it should be also 3 pi by 4 of a radian. Going to here, 225. 225 is actually 5 times of 45 degrees. So 45 was pi by 4. So 225 is a multiple, fifth multiple. So 5 times pi by 4 of a radian. 300 guys, 0 cancels, divided by 6 5 times, and this is 3 times. So 5 pi by 3 of a radian. Just check this out. 5 pi by 3 of a radian. Yes, perfect. Everyone? So now you know how to convert from here to here very easily. Very simple formula. So degree cancel. What remains is radian. So this conversion also you should be very comfortable with. Now, what happens is, many times this radian might be needed for arc measurement in many questions, maybe circular motion, rotational motion, or maybe some work power energy question. Many places you will see this formula being used. So say for example, you have a circle, and the radius of the circle is r. This is the center of the circle, and I consider a certain arc over here. I consider a certain, what do I consider? An arc over here. So that arc will subtend some angle, let's say theta over here. That arc will have some length. The best part is, the length of the arc of a circle is, simply put, the radius of the circle, or the radius of the arc, multiplied by the angle, but provided that the angle is in radian. If the angle is in radian, just multiply by the angle, you directly get the answer. So the length of the arc is simply the radius multiplied by theta, but that theta is in radian. Very important formula. L is r theta. You will be also using this in circular motion, rotational motion, etc. L is r theta. Okay. Oh, Siddiqui, you found this channel after a long time, I guess, and I'm guessing you are a 2026 aspirant or 2027 aspirant. What are you preparing for? Let me know. So if you just do that conversion from radian to degree, what will happen? Think logically. Okay. I want to convert that radian into degree. Radian into degree. See, if I want to convert radian into degree, or basically if imagine the angle is given to me in degrees, then what will I do to readjust this formula? Think logically. Imagine theta was given to me in degrees. I will have to get back this. So to bring it back into radian form, I will multiply it by pi and divide it by 180 degrees. So this will be the answer if theta is given in degrees. But if it is given in radian, then directly multiplied by r. Your job is done. You don't have to break your head. Okay. So Siddiqui, if you have less than a year and you want to understand physics properly, then I would suggest don't start with NCRT understanding part. Start that understanding part with a lecture, with a video class as much as possible. If you can manage time, maybe you are a full-time dropper and not a partial dropper and you do not have coaching, or even if the coaching is there, it is for a limited time. Try to read that same topic which the lecture is there, whether recorded live doesn't matter, before the lecture starts, just to get a hang of it. Even if you don't understand, it's okay. Just read that particular topic only. Let's say today Sir is teaching electric field. Only read electric field. Watch the video lecture. Solve the same questions as done in the class. Also do very laddu questions. H.C. Verma is a good book. In that there are not objective questions, short answer questions. Do those short answer questions. Or if you can find a book with very laddu questions, direct substitution. Tell the value, substitute, answer. Theory, statement based, direct answer. Very laddu questions, do it. And spend a lot of time on why it is, why not this, why this. Ask doubts to your teacher, ask doubts to your doubt mentor, whosoever is there. When can we use this? Why not this? All these sort of things. And then when you go back to the theory of your class notes or your textbook, read it properly and keep on questioning it. Why, where, when, how, then, not, why not, like that. And then go to average questions. And then after average questions, then go to PYQs. That is the flow that you should be maintaining. It takes time, but with a little bit of, I would say, consistency, it will become a very easy thing for you within a month. Okay, that is what you need to do, and you have to crack it in the first attempt because you have decent amount of time. Keep a target of November to December to complete the syllabus, so that from January to March you can do one round of big revision, or February, and then from March to April another round, and in last April you can do the third round of revision. That's what you need to do. Okay, I hope I have made it clear. All right, now that you understand, we can measure the length of an arc, okay, of any circle by radians or whatever degrees. So let's say, for example, an arc subtends an arc subtends 120 degrees. Find the length if the radius is 7 centimeters. Find the length if the radius is 7 centimeters. That's the question. Let's try to do this. First of all, length of the arc formula. Please remember, this is 120 degrees. It would have been r theta in radians, but in degrees, it will be r theta in degrees multiplied by pi divided by 180 degrees. Okay. Is the radius given? Yes, 7. Is theta given? Yes. 180 is 180. What is pi? I got an idea because 7 is there. Pi is 3.14, which is also 22 divided by 7. 7 cancels, as you can see very easily over here. This 0 and this 0 also cancels. 12 goes with 2, 6 times. 18 goes with 2, 9 times. That's all over here that I can manage. So I'm just left with 6 multiplied by 22, the whole thing divided by 9. So 22 into 6, 26 are 120, 2 6 are 12, so 132. So 132 divided by 9 is the length of the arc. Yes, 132 divided by 9. Everyone, that's how you can solve the questions, very straightforward. Yeah. I have just substituted the value of pi. If you don't substitute, answer will be in terms of pi. Else, you will have to substitute. That depends on the options given. See if pi is there in the options or not. Now, let's do another beautiful question. Let's do another beautiful type of question. And this is the last part of trigonometry, which you will be needing. This particular part is also called as the small angle approximation. Small angle approximation. What is this small angle approximation? If theta radians is very small, like 0.5 radians, 0.006 radians, 0.0782 radians, like that, very small, very close to zero. Okay, very small, zero, tending to basically zero. Then this is very important. Then these are the following things which are true. Observe this carefully. Sine of theta in radian is almost equal to theta, which is also almost equal to tan of theta in radians. Tan of theta in radians. Very, very important. And cos of theta in radians is almost nearly 1, in that situation, in that particular situation. Very, very important, guys. Okay, very important approximation formula that I'm giving you. If theta is very small in radians, then sine theta is theta, which is tan theta, but cos theta is roughly going to be 1. Let's put it to an use. Let's try to figure out something. Say, for example, I want to find out sine of 0.6 radian. 0.6 radian, or let's say 0.076 radian. What do you think the answer will be approximately? Because 0.076 is small, the answer will be also 0.076. Wow, that's so cool. Sir, what is cos of 0.0051 radian? Well, this is a very small number, so approximately the answer to this will be 1. Wow, this is so cool, sir. Sir, what will be tan of 0 point, or let's say, if I tell you, what is the tan of 11 by 2059? Chumma some random number. Well, this is very small, but this is in radian. So I can just say it is almost going to be the same. It will be 11 by 2059 because this is a very small number. So as long as the angles are measured in radian, the answer will be the same for sine and tan, but for cos, it is roughly going to be 1. This is called as the small angle approximation. Okay, but there is a catch in this, and the catch is when the answers are in degrees. That's where the catch comes. Say, for example, it is sine of 10 degrees. Don't say, sir, 10 degrees very small, chintu mintu angle, sir. So sine 10 is 10. Wrong. No, 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 no. Sine 10 is not 10, okay? So first convert the 10 into radian. Before that, don't do it. Okay, so sine of 10. I want to convert it into radian. Huh? So degrees into radian, what do I do? 10 into pi, the whole thing divided by 180. Wow. So 0, 0 cancels. So it will become sine of pi by 18. Oh, pi by 18, sir. Pi by 18 is a very small number. So this is approximately pi by 18 only. So the answer of sine 10 is pi by 18. So if it is in degree, convert into radian and then use that radian as the value. Let's do one more. If I ask you, what is the tan of, let's say something 0.07 degree. Okay, 0.07 degree. Very small angle. So I can say it is tan of 0.07 multiplied by pi divided by 180. Okay, this is in radian, of course. This is in radian, of course. Since this is very small, I can approximately say it is 0.07 multiplied by pi, the whole thing divided by 180. That's it. Once you convert into radian, that radian value comes as it is. As it is. Okay. Similarly, if I tell you what is cos of 5 degrees. So now you will think cos 5, sir. Cos of 5 will be cos 5 into pi divided by 180, but that is in radian. This is a very small value. So this approximately will be 1. So that's how you solve it. So this is a very important note. If the small angle is in degree, and typically that theta degree is less than 30 degrees, then it is small, then convert it into radian. Convert into radian. Very, very important. Before using approximation. Before using the small angle approximation. Is this absolutely clear, my dear students? Everybody with me? Before using the small angle approximation, use this. Without that, don't proceed. Without that, do not proceed at all. Very good. Amazing. Now, this you will be needing it later on when the chapter of waves, etc. comes, which is the graphs of sine, cos, and tan. I will just put it over here. I'll just put it over here. Sine, cos, and tan graphs. You will be needing it. So, let's say here we have theta, and here we have sine theta, sine of theta. Then you have cos of theta, and then you have tan of theta. How will these graphs look like? The graph of sine theta looks like this. The maximum value and the minimum value are +1 and -1. Very, very important. So sine theta can never ever exceed 1 and can never be below -1. So this is the minimum value and this is the maximum value. Sine of, you can see, this is 0 degree. This is again 180 degrees. Sine is also 0. Then again 360 degrees, sine is also 0 and it repeats itself. In between, whatever you get over here, this is at 90 degree and this is -1 at 270 degree. Sine 0 is 0, sine 90 is 1, sine 180 is 0, sine 270 is -1, sine 360 is 0 because 360 means you're back. It's as good as 0. So again it repeats itself. So it will be between 1 and -1. What about cos, sir? Sir, what about cos value, sir? Cos starts from 1. It it goes like this. Cos starts only from 1. It will go like this beautifully. So obviously this is 0 degree. Cos 90 is 0, remember? And cos 180 was -1. Cos 270 is 0 and 360 is back to 1. Again, cos is also between +1 and -1. So cos theta is less than 1 or equal to 1, but it is always more than -1. This is the minimum value. This is the maximum value. This is how the cos graph looks like, curve looks like. Tan graph is very nice. It goes like this, and I need to draw these lines. They look like this. Yeah. So as you can see, tan of 0 degree is 0, tan 90 is not defined, but again, when you go to the second quadrant, tan is negative. In the third quadrant, between 180 and 270, it is positive. Again, it goes to 0 and again it comes back over here at 360 degrees before again repeating the cycle. So tan graphs looks like a curve like this, zooey, zooey, like these curves over here. And you can see tan values extend till infinity and go also till minus infinity. So from minus infinity to plus infinity, tan can take any values. Tan can take any values. A big range is there. Okay, so tan range is very, very huge. It can be between minus infinity and plus infinity. Okay, this is how it goes. Tan 0 is 0, tan 45 is 1, tan 60 is root 3, tan 80 will be even more, tan 89.9 will be very big number, 1 lakh, 2 lakh, like that. And then 90 degree can't be defined. Beyond that, again, zoop, again comes back, again comes back. So this happens at 90, 270, like that, multiples of 90 degrees. So these graphs are also very crucial. Sometimes graph based questions also come in physics. Okay. So those were your questions, guys. So homework question already given, cos 120. Answer it in the comment section. And remember that if you are looking for a full-fledged batch where you want the complete NEET syllabus, JEE syllabus, you want to recommend Vedantu and you love the way we teach over here, then guys, do not hesitate in reaching out for support. At least visit the center once. I'm not saying join it or anything. Just visit the center, just have a look. Just meet the teachers, meet the doubt teachers, meet the mentors are there, student academic mentors. There are counselors who take care of not only your academic support but also your non-academic support, like managing timetables, managing school, you're facing some emotional problem, whatever. Meet the doubt teachers who are separately sitting over there, see how they are interacting with the students, see the digitized classroom, see the clickers, get a feel of the entire thing, and see the library, see the study room, everything, all the facilities, and then make your informed decision. Okay, because this journey is not going to stop in 1 week or 2 weeks, and it can't be done in the last few months also. So it's a long term game that you have to play. And if you are looking for this long term game, the best thing that you can do is visit the Vedantu learning centers at so many different cities. We have a new one in JP Nagar in Bengaluru. So that's why I showed it to you. Also, the best part is right now the scholarship entrance tests are on, which means if you are visiting the center and you're booking your slot and you give the test and you get a good score, you will be getting a good discount on all the batches which are for 1 year or 2 years. So you can get up to 90% scholarship. So your fees will be off by a considerable amount. So let me show you the link which is there right now into the description box of this particular video itself. As you are watching it, just go down and you will see it right over here. Yes, fill the form for the offline batches to book your slot. Explore our offline centers, book a slot now, book a visit now. Enter your name, grade, phone, and preferred city. Many options are there, be it Tamil Nadu, Andhra, Telangana, Karnataka, Maharashtra, Punjab, Delhi. So many places are there. Okay, we are almost covering majority of our country. So book a slot and see what can be the best thing for you. And if your center is not close by, we do have our pro batches too, which are exactly the feel of offline, but at the comfort of your home. Maybe there is a center, but you don't want to visit the center. You want to study at home on your computer. You want to save time, money, energy. Then we have our batches. You can call us on this number, or best is you can book your seat over here in this particular link. Okay. So that was all about today's class. I hope you enjoyed and learned a lot about trigonometry and geometry. So we'll continue this series in the days to come. 6 o'clock 11th standard, 8 o'clock 12th standard. This was your Captain Shreyas signing off. Bye bye. Take care.